Hello, my name is Sergej Harder and I work as an engineer at Sika. Off-highway vehicles play a critical role in a wide range of industries, from agriculture and forestry to construction and mining. The cab typically has a box-like structure with a rigid frame made of high-strength steel or aluminum. Key elements to the safety concept of cabs are the so-called rollover protective structure and the falling object protective structure, or short ROPS and FOPS. As the names indicate, these structures protect the driver from rollover and falling objects. Welded cab structures are designed by joining metal components through various welding processes. They are a proven technology with a long history of success in the industry. However, there are some challenges to consider. The welding process can be complex and labor-intensive, weld distortions often occur, and due to the heat input, the base material can be weakened. Therefore, we set out to prove that an adhesively bonded solution can eliminate those downsides, save costs, and create additional value. With Advante, we aim for a fully bonded cab structure to tackle the challenges of present cab design and manufacturing without sacrificing on safety and reliability. The fully bonded cab offers a significant advantage in terms of reduced production costs, as the assembly with adhesives reduces time and labor required from the production staff. Adhesives offer a distinct advantage over thermal joining technology, as they do not introduce any thermal distortion or damage to the materials being joined. Given that the application of adhesives is a comparably clean process, it offers new possibilities for modular designs and manufacturing. That's why we put the concept to the test. We built the core components of the cab and tested them virtually as well as physically to show the ROPS and FOPS compliance. Finally, we built a full-size prototype cab to show the manufacturing advantages of the concept. Now, what does our concept look like? Here you can see our vision of a fully bonded cab exemplarily mounted onto a tractor. Let's first look at the roof assembly, highlighted on this slide. The assembly consists of nodes that connect the horizontal square hollow structures with an adhesive. The same concept is applied to the floor assembly. As previously mentioned, the application of adhesives needs minimal protection. Components like electronics or surfaces in the cockpit area can be mounted before the joining of the roof and floor assembly. This also implies that the roof and floor assembly can be painted or powder coated before joining both. Now let's have a closer look at the node design. A key feature of the fully bonded cab concept is the node design. It consists of a body that is hollow to enable the routing of cables. The corner is rounded to reduce stress concentrations. The plug-in adapter is used for the centering of the node and the square hollow structure. Depending on the connecting elements, the geometry of the plug-in adapter can be adjusted. Additionally, the step of the centering section is used to limit the adhesive flow outside the designated area. The joining channel is the area where the adhesive connects the node to the square hollow structure. It is designed such that it loads the adhesive mainly in shear and provides sufficient area. Depending on the structural requirements, the length of the joining channel can be adapted to meet the desired needs. The adhesive itself is applied through the application opening. In a manufacturing scenario, these nodes can be produced by casting from a high-strength steel. For higher volumes, this can be done with low costs. Usually, the tolerances of the castings are sufficient for a proper adhesive application and profile centering. For higher tolerances, post-processing may be necessary. The joining between node and square hollow structure can be demonstrated best if we look inside the cross-section of the joining area. We will have a look at this in the next part.